Today we're going to take a look at using our right triangle trigonometry that we used in 13.3 and use it to solve to find missing measures. So I was able to find an interactive version of our calculator, so as you can see it's here, so you'll be able to see what I'm punching into the calculator to get this information, which hopefully will be better than just the screenshot we had in the last video. So our first example, and I've got all our different ratios here, so hopefully that'll help as well. We're going to look at this first angle. We got triangle ABC, and we got angle B measuring 67 degrees, AB being 20, and BC being relative to A. So I know in looking at this, I need to know what is going to incorporate angle A, side length BC, and side length AB. So if I think about this, this is going to be my measurement here, which is my hypotenuse. And compared to angle B, A is my adjacent side. So if I look at my ratios, adjacent over hypotenuse is going to be cosine. So I'm going to say that the cosine of 67 degrees is going to be equal to the adjacent side, which is A, over the hypotenuse, which is 20. And in doing so, we get that we have A over 20. Now I want to solve for this A. So to solve for A, I'm going to multiply both sides by 20. And that cancels here and leaves me with A. And then on the other side, I've got this 20 times the cosine of 67 degrees. So what I want to do now is I want to go here, I'm going to click on my mode. I see mine's in radians, so I'm going to arrow down, arrow over to degree, and hit enter. So now it's on degree, and then I'm going to clear out of there and exit, which would be second mode to quit. And now I'm in my screen, I'm in degree mode, and I'm going to do 20 times the cosine of 67 degrees. I can close out my parentheses if I wish, although not necessary. I hit enter, and I get that A is equal to approximately 7.8. Moving on to my next example. I've got for B, that we have triangle ABC again. I don't know the measure of angle B, but that's what I'm trying to find, is this right here. And I see that I have side lengths of 8 and 13. So if I look at this, I can identify that AB, which is 13, is my hypotenuse because it's my longest side opposite the right angle. And 8 is going to be my opposite side because it is opposite the angle that I'm looking for. Opposite over hypotenuse is sine, so that means that I'm going to do the sine of angle B is equal to the opposite, which is 8, over the hypotenuse, which is 13. So now I need to get rid of that, and so we're going to do what we did when we were working with this in 13.3. And to get rid of this, we're going to do the inverse sine of 8 over 13, and that's going to be equal to angle B. So if I punch that into my calculator, I hit second sine, so the inverse sine of 8 divided by 13, close off my parentheses, I hit enter, and I get 37.97987244, which we're going to say that the measure of angle B is therefore equal to 38 degrees. Now we've got that we have finding all the missing sides and angle measures. So we look here and I see I need to find these, so I'll fill in what I know. I know that angle C is 90 degrees. I know that CB or BC is 2, and I know that AC is 7, which makes my work a lot easier. So to find AB, I can do it one of two ways. I can, which would, the ideal way is going to be to use Pythagorean theorem. Otherwise, you can find one of the angle measures and then find it. But I'm going to use Pythagorean theorem. I've got 2 squared plus 7 squared is equal to c squared. 2 squared is 4, 7 squared is 49, and that equals c squared. So c squared is equal to 53. That means that c is equal to the square root of 53. Now that I have that measure, and I'm going to write that down just so I have it here for the drawing, making our lives easier. I know that if I'm looking for the measure of angle A, I know that if I, just in case I made a mistake with C, I want to use the opposite over adjacent with the 2 over 7. So that tells me that I'm going to use tangent. So the tangent of angle A is equal to 2 sevenths. So that means that if I take the inverse tangent of 2 sevenths, I'm going to get the measure of angle A. So on my calculator, inverse tangent of 2 over 7, and I get 15.94539, so I'm going to say 16 degrees. Now the nice part is, triangle sum theorem says that a plus b plus c is going to be 180, and also because we have this right angle here at c, I can take a and b and that should equal 90. So 16 plus x, which we'll say is the measure of angle b, is equal to 90. So if I take 90 minus 16, 90 minus 10 is 80, minus 6 is 74 degrees. And when I do that, the next thing I want you to do now is give the U-try problems a shot and see how you're doing with them. Bring your questions with you to class and have a good rest of the day.